Okay, this is part 4 of question 2. As a result of the ball striking the spike is driven a distance of 7.3 times 10 to the negative 2 meters into the wall. Calculate, assuming it to be constant, the frictional force F between the spike and the wall. Okay, so I again highlighted the givens in blue. The unknown is in green. And I've started to evaluate the problem. I wrote some of the givens from the previous question, part 3 of question 2. The kinetic energy is equal to 45 joules. All right. When I'm evaluating this here, I figured out that I was given a distance or a displacement, all right, and I need to find the force. And I remember in the last question I was given the kinetic energy. Okay, and if this spike goes into the wall and comes to a stop, all of this kinetic energy disappears. And the reason that it disappears is due to the force of friction doing work on the spike to stop it. Okay, so what I can do here is I can use work equals force times distance or force times displacement. It's used interchangeably here. All right, and I know this number. I have this. 45. I don't know the F, but I do know the S. So what I need to do is get F on one side by itself. I divide both sides by S. W over S equals F. Okay. Now let's go ahead and plug in some numbers here. Okay. So the work done was 45 joules, and the displacement was 7.3 times 10 to the negative 2 meters. Okay. When I do this calculation, I get a force of 6.1. F equals 6.1 times 10 to the 2 newtons. Okay. Or 610 newtons. All right. And if you get around that number, it's perfectly fine. Okay, it should round to about 6.1 though, 6.1 times 10 to the 2. There's another way to solve this problem here. Okay, I know that the final velocity is 0. The initial velocity, I know that to be 4.54 meters per second. And I know the distance that it traveled. So I can actually solve for the acceleration and multiply it by the mass to get the force. I have the mass of the spike and the ball is 4.3 kilograms. All right. So first of all, I need to get A on one side by itself. All right. V squared is equal to 0 because the final velocity is 0. The initial velocity, though, I have that. So 0 equals mu squared plus 2as. All right. I'm going to subtract 2as from both sides. Negative 2as equals mu squared divided by 2s. Divided by 2s. A, actually I should write negative a, is equal to mu squared divided by 2s. And the reason that the mu and the a are opposites is that the force was acting in the opposite direction of the velocity of the spike. All right, because the force, which is mass times acceleration, is slowing down the spike. All right, so let's plug some numbers in here. Okay, negative a is equal to mu squared, which is 4.54 squared divided by 2 times 7.3 times 10 to the negative 2. Okay, A equals 141. Oh, sorry, this is meters per second. Okay, and down here this was meters. Okay, A is equal to 4.54. Yeah, divided by 2 times 7.3 times 10 to the negative 2. And my resultant force, or my resultant acceleration, is 141 meters per second squared. 141 meters per second squared. Okay. Force equals mass times acceleration. Okay, I take 141 and I multiply it by 4.3. Okay, 141 times 4.3 kilograms. 141 meters per second to the -2 is equal to 6.1 times 10 to the 2, 610 newtons. Okay, done. Next question. Oh. The machine that is used to raise the ball has a useful power output of 18 watts. Calculate how long it takes for the machine to raise the ball a height of 1.6 meters. All right, so I know that I need to use this equation, power equals work divided by time. All right, I know that the power is 18. All right, and I know the work done. The work done I got from the first question. It's 55 joules. Okay, and I got that from calculating the velocity of the ball times the mass. All right, velocity of the ball squared times the mass times 1/2. Okay, and if you want to know how to do that, go back to the second video. Actually, the third video. There's so many videos for this question. It's a long question. Okay, power equals work divided by time. I manipulated this to make it time equals work divided by power. Okay, now that I've done that, we're going to plug in values and solve. Okay, S, my solve step. Okay, the work done is 55. Okay, 55 joules divided by 18 joules per second, which is a watt. Sorry, I wrote this per seconds differently than I did up there, but that's okay. Joules, 55 joules per second. You do that calculation, okay, and here I can cross out joules and seconds goes on top, and I end up with 3.1 seconds. Okay, that's it. Last question. Okay, check back with me for some other videos in the future.